we're really pleased to announce that Jack Lonsdale is going to speak for us. He's in Leeds, he's based over there, and he works for Stantec, who are an engineering firm focusing on the clean and wastewater industry. FME allows him to express his problem-solving mindset in a digital way, and the project he's going to explain to us today is how he's been using FME and its raster interpretation capabilities to automatically digitize utility plans. So go for it, Jack, and over to you, and thanks for joining us.
Thank you very much. Yep, thanks for the introduction. So a little bit about myself. So I'm a graduate analyst at Stantec. I've been there since about October 2018 and picked up FME sort of in my first couple of weeks there and been using it daily since. So I work within our digital water services, which is looking at promoting innovation and digital solutions for the UK water industry. As a company, we have contracts and projects across all major water companies, looking from everything from clean to waste and anything in between. We use FME in general for custom tools and geospatial investigations, and basically trying to improve the services that our clients can offer. So my talk today, which as people probably notice, has a title full of the industry buzzwords. And you may argue that some of the things we're doing are already digitized, and the plans were never static, but it sounded good, so I went with it. And what I'm going to talk you through is how we've identified a slow process that we do in and try to optimize that through the use of FME. So I've got a quick agenda to share with you all. So firstly, we've got a safety moment, which is one of our corporate policies, just to give everyone a minute just to sit back and consider either well-being and safety, which I think is quite pertinent in the climate we're in now. I'm going to outline the objectives of what we try to achieve, some of the challenges that were sort of apparent from the start, the solution that I came up with, the results because of that, and then some quick benefits and tips just to sort of top it all off. So a quick safety moment, I think it's really pertinent for your well-being in these times, as everyone's probably sick to the back teeth of hearing of the whole coronavirus lockdown, every single word about that. I think it's really imperative that we all actually manage his mental health quite well, as well as his physical health, especially in these restrictions. I'm personally lucky that I have this image on screen on my doorstep to go for a walk every day, which is really useful and clear in my head, especially when working from home. I would encourage everyone to try and do that to their best ability whilst adhering to government guidelines. So onto the FME. So the objectives that we tried to do was input multiple static, we refer to as static plans. We want to digitize and distinguish key asset features. We want to then scale and geolocate them, right to a GIS output for the end goal of combining to a singular area overview. Now, what the process was actually, so some context behind this. As a partner to water companies, we often have a group of civil engineers have to scope up what tasks have to be done on site. And as my title suggests, my talk, it really is crowded down there beneath the roads and beneath the streets. And we need to have an understanding what assets from other companies are there before we go in there and stick a spade in the ground. Hence, unless we go through cables and things like that, I'm sure everyone's heard horror stories of their internet going down. And what we have, we send a request to a provider. They provide us with PDFs or PNGs or sometimes even scanned copies of these utility plans. And what we have usually is a graduate engineer having a plan on one screen and some sort of GIS software on another screen and manually draw approximately where these lines might be. Obviously, you can probably imagine when there are things on large scales and large areas, this can be really, really painstaking. So we thought, well, there's better ways to free up our engineers' time. Can we do some sort of automation with FME? So some challenges for us. So initially, we had to deal with, they had a mixture of encoded text strings, but also just raster text. So where we were able to actually, the computer was able to read the text, but also where you could visually see it was text, but there was no highlightable feature when you open it up in Adobe, for example. A lot of different formats. Sometimes I've got them as PDFs, sometimes I've got PNGs, sometimes I have to scan them in and get them for a format like that. There are issues around watermarks and quality, whereby there was a watermark that just said something like not suitable for construction use, and that obviously faded the information behind it. and obviously things like quality, where things aren't sharp, not printed with as many pixels in it, and things like that. Page orientations, having to deal with both landscape and portrait ones, which was an unforeseen one, but came about and we had to deal with that. And also whether our plans had the required geospatial information. Whilst we perhaps know from our sort of files investigations where something might be, we had to ensure or make sure that there was something on that plan that told us where in the world it was, and also how large it was, what sort of scale it was. So what was the solution to all this, really? So the solution that we came up with as an overview was to actually make one workspace per utility provider that roughly went through the same process. In order to automate it, we needed a standardized input format, which was sort of achieved by doing one workspace per utility provider. We found that things like BT always came in a set format, things Virgin came in a different but also consistent format. It was then determining the presence of digital features, mainly whether we had that encoded text or there were any vectorized features, or it was all a raster to try and deal with. We then had to extract those geolocation features. Firstly, we needed to make sure we could place it where in the world it was, and also make sure it was the right scale. We then filtered for the required asset data, whether this be the lines representing cables or the lines representing pipelines and things like that. It was then taking that raster information, converting it to a polygon and cleaning up that data. But also had to make sure we could utilize the fact we could define attributes for that. It's all well and good just pulling out features, but when we can interpret that, we know it's a red line. The red line represents high voltage or high pressure, for example. We want to make sure we can keep that attribute to inform information at the other side and enable effective symbology at the other end. Just move on. Okay, so the solution for extracting geolocation features was where I found a really exciting bit of FME I was able to use that really opened up the opportunities we could do for different uses for this. So as I said a few times, we definitely needed the coordinates and scaling information required. For example, we were given a coordinates of the map center in a British National Grid coordinate system. Great, we know exactly where that map center is in the world. We're also given a scale, 1 to, as I say here, it was given exactly to 1 to 3, 4, 5, 1. Again, we can use that to determine how big something could be. We've got that and clipped the page, whatever, imported the PDF, for example, into the workspace. Use a creator to set a box around where this information is, the map center and scale. Clipped it, so we just had those features. And then the really clever bit was either using the existing digital text just to put it through a text property extractor, or actually use some optical character recognition software, free open source software that's really well integrated with FME called Tesseract, and use the transformer you see, the Tesseract caller, to then interpret that text to extract it for features to use. We can then set the coordinate system and page center point, and then we can actually move on to scaling. So the challenge with scaling is that the scale you see on screen, for example, the 3, 4, 5, 1, isn't the actual scale at which FME will read it. It'll read it in some sort of local coordinates on a local scale. But because everything comes in a standardized format, you can actually do something that I termed relative scaling. If you can make sure through trial and error that the output is where it is and matches the input, you can then scale everything relative to that set point. So you know that if you get the 3, 4, 5, 1 scale right, any numbers you pull out from future plans, if you relate it back to that scale, you can make sure it does it automatically correct every time. The next part of the solution was filtering for required data. So we know when we look at a plan, the required asset data is viewed as a coloured lines. The example you see on screen, we've got asset data represented by red lines, we've got some blue and some purple in there. And that sort of twigged with me, well, if that's how we interpret it, by seeing a combination of colours, can we teach FME to do the same? And the answer was yes, fortunately. So we can actually use the raster expression evaluator to create acceptable ranges of colour to just filter out all the noise and keep those required features. So I could tell the expression evaluator, okay, given my red, green, blue colour bands, what's an acceptable range that will allow through all those red features? What's down a different stream? What's an acceptable range to allow through all those blue features? And likewise. Then post it into a raster to polygon coercer, and we get then a GIS featured out. We've already geolocated it, we've already scaled it, we've brought out the features we want, and now we've got it to our GIS output. What followed a little bit of cleanup, as you can, I don't know if you can make out on the plan, but there's things like accompanying text which match the color of the pipes. That's an unnecessary attribute, an unnecessary feature that we don't want to come through into our final output. But provided it's separate from the actual pipe and isn't dissolved into it, then we can do some area calculations and then allow a tester just to get rid of anything that's below a certain area. And again, a bit of trial and error can tell us a good happy medium for that. And finally, just define some attributes for it. We know red, for example, is high pressure, blue is low pressure, whatever it may be. Define those attributes and export them. What was really good here was, depending on what civil engineer wanted and stuff like that, you could use the attribute to define a site name and then use the fan out option to create different files for different sites, or lump it into one central geodatabase, for example, for ArcMap to read, to then make a plan of that. So just a quick look at some of the results now. So what you see on screen, so the top one is a BT plan that came in as a PNG image. The bottom was National Grid gas file that came in in landscape with a watermark over it, and the output is what we produced in ArcMap afterwards. So as you can see, it's actually geolocated it quite well. Obviously, you do get through some of the assets such as the BT boxes and things like that, and there is a little bit of text that's come through from National Grid, but overall for its purpose, which is just to give a really high level overview of the area, i.e. it can tell us engineers is something there or isn't, it was really effective. Another example now for Virgin Media, where the red lines have been filtered out and now is plotted against OS master map, and again has geolocated those features quite well. So what are the benefits of doing this? So apart from saving engineers time, which is the obvious thing, you can obviously batch process through hundreds in a few minutes. As I described, that manual tracing method, it can save weeks, literally weeks of work, and someone at the other end, I think they would thank me for that, because I can imagine it'd be very, very mind-numbing just to manually trace plans day in, day out. Because we got all those outputs in a digital format, in a GIS output, we can actually combine all of them on top of each other to give an overview of the area. And what this can do is identify really, really quick wins and also early foresight of challenges. And what I mean by this is, if we're looking to put a pipeline somewhere and we have a few different options, we can identify straight away that, okay, there's a lot of assets, it's really busy underneath the ground here, or there's an area over here that we're thinking about and there's actually nothing there. So it can really quickly and visually identify that. And it can also, in another vein, if we have to put a pipeline somewhere, it can give an early foresight saying, hang on, there's a really, really high voltage electric cable there. We need to be really, really aware and investigate that. And as I've mentioned, we actually use attribute designation really well, and that allows for really effective symbology. If you know some things have to be colored up really bright to catch the eye, you can do that, and it keeps those attributes and keeps that information. So some tips about all this that I found really useful. So this is my first time using PDFs, and it was useful for utilizing the feature attributes of that. So PDF page number, for example, a couple of the utility plans we got were almost like a letter format, and the front page was just an unnecessary letter detailing your request. We can use a PDF page number attribute to immediately filter those pages out, and then we don't have to worry about them. Yeah, the open source character recognition, the Optical Character Recognition software Tesseract, free and open source, integrates directly into FME, I believe, from 2019.2 onwards. Really, really useful. I haven't found it's given me a wrong result yet, which is really, really good. Be aware that I had to be of large and approximate scaling. If you can imagine, if you scan a plan you're trying to process is at a 1 to 5,000 scale, any little discrepancies in your geolocation, it will amplify over that scale. And also approximate scaling, if you've got a plan that says roughly 1 to 2,500, and you're using that number and it's exact, you may encounter issues there. Awareness of your local coordinates, for example, right back at the start when we're trying to clip the necessary text features, that's usually in the local coordinates of the PDF, so be aware of those, that you can view them in Data Inspector and see where those bounding boxes are. And again, a lot of colors won't be exactly the same shade of red throughout, so I utilized a range of RGB combinations rather than just saying you must equal this specific value. So yeah, a nice little slide just to sort of epitomize what we're about as a company and what we're trying to achieve. and how vital it is, especially in these current times, for us to innovate. And I believe FME has really allowed us to open the door. So that this is just one of the many tools we have been creating through FME, and hopefully this is the first of many presentations to share some of those with you. So thank you all for listening, and I welcome any questions.
That's great, thank you, Jack. We have got a few. First of all, I'm going to make a comment, and that's just that I also rate the Tesseract caller, so I was really pleased to see it in your session. It does rely on a third-party component to put on your machine, but I think it'd be interesting to see how some of the machine learning tools that are into FME in the last couple of years might help you as well. I'm thinking particularly of tools like the Azure Computer Vision API that might be an option from a text detection perspective.
Yeah, definitely. And I think things like identifying cracks, that you put a showcase on that in a runway, would be really useful for us for identifying where the assets are degrading and things like that. So yeah, definitely an exciting prospect.
Okay, and so we've got a couple of questions from the floor. So what happens if different plans need to be different scales? So a building plan, for example, might approximately be scaled at 1 to 1,000 scale, but a town centre plan could be 1 to 10,000. So would the workspace work with plans at different scales?
Yeah, so that's where sort of the clever feature of relative scaling went in. So if you import a plan at 1 to 1,000 and make sure that it's all scaled correctly, if you then put that as a scale, as an attribute, you can relatively scale at 10,000 against that. So when you use the scaler to set your scale, you can automatically do that relative to the initial one you've set. So yeah, it's as long as you've set the first one up correctly, it can read any scale and make it relative back to that and scale it successfully.
Okay, brilliant, thanks. And could this process be used to update utilities as they continue to be laid? So I guess that's around dealing with more live data sets.
Yeah, I mean, I think the process is a little outdated that you have to request them from a provider. But if you set some sort of, I don't know, possibly of an API, if there was something set up at the other end, or just an automated workflow to request it periodically, you could then, yeah, set up a full sort of front to back end workflow to update your personal records in your company of where utilities are.
Okay. Was there in terms of the data that had been turned into vector as a result, did you have to do a lot of manual QA afterwards, or was that did it come through in a relatively okay structure?
In general, it was relatively okay, but it almost came, the use of this tool, like in future use, comes with a strong caveat that it's not for 100% accurately saying it is in this particular place. It's more for a high-level overview of engineers doing that initial assessment to say, okay, is there something in this region or not? Almost like a presence thing, that, okay, there is this, therefore we have to do further investigations. But yeah, in most part, I didn't put the data cleaning using areas at first. Then I found that just getting rid of those little tiny features that I brought through really helped sort of make a better output, really.
Okay. And we've got lots of requests for you to share your process, but I suspect that as a commercial organisation yourselves, you'll have something you might want to say about that.
Yeah, unfortunately, I don't think this workspace is something I can currently share because it just gives us a slight edge in streamlining our internal efficiencies. But hopefully what I've given you is a couple of ideas to how you could go away with that and sort of utilise it for your own benefit.
Brilliant. Okay, well, really appreciate you sharing that, Jack. Thank you very much.
Cheers. Thanks, everyone.